The man on the planks is Peter Styron, and when he's not risking life and limb on the ski slopes, Peter is a professor of chemical engineering at Sheffield University.
Oh, that was amazing. Really smooth.
In fact, Peter is at work right now. For the purpose of today, this ski slope is Peter's laboratory, and his experiment, his skis. If Peter's invention proves to be as successful as he hopes, he may well be on the way to engineering Olympic gold for Britain's skis. It all started with Peter watching some young skiers at Sheffield Ski Village.
Well, this project started on a day like today. I was at a race, it was dry, it was sunny, and I wasn't going very fast. I saw lots of kids. They were behind the start hut, they were putting on different waxes and lubricants such as furniture polish, back to black, all sorts of things. And it's all very well for the first 10 metres or so, but after 10 metres it wears off and you're left with a quagmire of different solutions, different formulations all over the slope. It makes the slope slippy, it doesn't make the skis very slippy after that 10 metres. And I decided that, I'm a chemical engineer, there must be some better way of doing it than that. Now, what would have been an ideal situation, not very practical, would be to take a furniture polish can and strap it onto a ski so that it gives a continuous flow. That wouldn't work. So we decided to look at a more elegant system, something which would apply the lubricant continuously over the whole race, not just that first 10 metres. And that meant going into the engineering labs and designing a whole new ski system.
As a chemical engineer, a lot of Peter's work is aimed at ensuring a continuous flow of liquids, so his new ski design wasn't too much of a challenge.
The original prototypes weren't that elegant, just this cup strapped to the ski. However, the lab tests were very successful. That gave us encouragement to go out on the slopes, and the slope tests were great. We got some really good results. So we continued and we refined the design.
Not only did Peter have to refine the ski design to comply with competition regulations, he also had to formulate a lubricant. Of course, Peter didn't just invent his lube out of thin air. He'd already seen what the kids on the artificial slope were using, and he already knew plenty about the chemical properties he was looking for from his lubricant.
Furniture polish would be good because it's a fluid and you can move it around. The problem is that it's not very good for the environment. So we can't really put that onto a dry slope. We need something that's environmentally friendly and biodegradable. The original design of the lubricants was based on what skiers were using, so it was fairy liquid and vegetable oil. That was fine, worked in the lab, but vegetable oil goes off. It goes rancid. You really don't want to smell that when you're skiing. So we started to refine it. We started to look at different additives, including designer polymers. And these gave us the properties we wanted, but with a long shelf life. We came up with a list of probably 5 or 6 different polymers, and we added them together in different mixtures to give around 100 formulations. So the formulation is very simple. You take 2 quantities of reagents. Here we have the base liquid, and here we have the additive. And we just mix them together in known proportions, and we get the formulation. Now we can use that on several skis. We can test it extensively. If it's looking good, we then make it in larger quantity and we go out into the field. Before we took them into the snow environment, we had to test to see if they froze. So we just did simple tests where we took the formulation in a bottle, stuck it in the freezer, and if it froze, we discarded it. If it didn't freeze, then we took it through to the next stage of development. We looked at the thickness of the formulations just by simply passing it through a tube and measuring how long it took to come through a small hole. The thicker lubricants didn't flow as well, so we discarded those. Some of the thinner ones flowed too quickly, we discarded those. It's a balance between thickness and speed of delivery. The first system, when we had the plastic cups on the old skis, these were 1980 skis, these were old skis. The feeling was just pure exhilaration, the speed I'd never experienced on a dry slope before. I remember shouting into the first turn, it was just such an experience. The original prototype wasn't very flexible, the aluminium wasn't flexible. So if we look at this one, this is one of the more recent prototypes where we've replaced the aluminium rise plate by a plastic one. And now we can see it's much more flexible. We've got the rise plate, we've got the filler, but we also have this tube which runs from the rise plate down to a point at the top of the ski. If we look on the bottom of the ski, then we have a hole where the fluid is released from.
So we got some results on the slope, really good, we were going really fast. But what we need to do is we need to quantify the speed and the relative performance of the different lubricants. So what we do is we come into the lab. So we've got a piece of the dry ski slope and we've elevated it on a plank of wood. We have a lab jack which we're going to raise and lower so that the ski starts to move. We've also marked on the floor a mark which is exactly 1 metre. So we're going to keep everything constant. We're going to keep the dry slope matting constant, the ski constant, we're going to change the lubricants. Okay, so to do the tests, what we do is we put the ski onto the piece of dry slope matting. We always put it in the same place and we run this test repeatedly. So we put the ski around there and it shouldn't move. So what we need to do now is we need to change the height of the jack. And we're looking for the point at which the ski first starts to move. As you can see, it's now starting to move just a little bit more. And there we go. It's a slow movement, but that is where we've overcome friction for the first time. What we need to do now is go and measure the height at the 1 metre point. Okay, so here's a ski that we've now primed with lubricant. We're going to do the same test, but first we've got to make sure that the lubricant's running properly. So we're going to put this onto the slope and just run it backwards and forwards a little bit, make sure it's spread. Okay, you might be able to see on the bottom of the ski that some of the lubricant is coming out of the hole at the bottom. Okay, so we put that back into position and we now need to go back to the lab jack and get the things moving. Okay, so we put the lab jack up. Hopefully this should be at a lower height than we saw for the unlubricated ski. And there you go, you see it's starting to move reasonably freely. As you can see from the results, we didn't need to raise the matting as high for the lubricated ski. But one test doesn't prove anything. We have to do this repeatedly to get accurate results. In the case of reliability, if we take one measurement, it may be a completely freak result. The more results we take, the more faith we have in the results. In order to get reliable data, we needed to do the experiment for each lubricant a minimum of 50 times.
And all that testing took no less than 5 years.
We needed to be sure that it worked on snow because to be able to sell this, a company would need to use it with their top racers in the World Cup and the Olympics. They need to win medals. If they win medals, people see the skis, they go out and buy the skis. You're talking about a multi-million euro industry.
So Peter's design looked good on paper, but in the real world you don't ski on paper.
We've seen the test done in the lab. You know, that could be done in any location. We've seen the test done at Sheffield Ski Village. That gives us a good handle. That gives us an idea of what we can expect from some of the lubricants. But there is just no substitute for getting out into the Alps, into real snow, and testing the skis in real conditions. After all, this is where the skis are going to be used. So in terms of the reliability, what we're going to do is we're going to run the test at least 3 times for each lubricant. The more tests we get, the better, because we can take an average over all those runs. In terms of precision, we're going to use the best timing equipment we can get our hands on. That's going to be precise to 1,000th of a second.
And by getting the skiers to adopt the same position on the same slope in the same conditions, Peter should get very reliable data.
The results actually look quite good, which is encouraging. Yeah, that's one of the big problems with being out in the Alps, that things can go wrong when you least expect them. But these results, from what I can see just from looking at the paper, they look really good.
The results are encouraging, but the next step is to put them in graph form.
Good morning's work. So, we're just looking at the results from today's test and they're looking really good. When we had the two skiers skiing together with no lubricant on, then the times were almost identical. When we put the lubricant system on, then the guy who had the modified skis, his time suddenly got faster and faster. But we had this guy coming down as the control. Okay, so we were checking his time all the way down. He was keeping the same speed, he wasn't increasing. And that's really good because that tells us that the skier with the lubrication system on isn't releasing any of the wax onto the surface, which will affect the skier behind. The results, they're good, but we didn't do this in a true controlled blind fashion. So the skier who was on the modified skis, he saw us putting something in there. So while the results today are good, we'd really like to go off and do another blind control session. I'm looking at some data now from some of the previous runs on snow, and one of the things that we do is a run history. So we look at how the speed changes as the ski travels down the slope over a given distance. And what you see here is that for the normally waxed ski, the race wax, the speed decreases or the time increases because, of course, we're measuring time. So the time increases, we then switch on to the Wildfire self-lubricating system and you see the sudden dramatic drop in times as the speed increases, and that's maintained all the way through the run, so it doesn't deplete, it actually maintains a constant level, and that's the sort of performance we're looking for. No variations over a run. This table shows the results of numerous tests that we performed, averaged out to give us an indication of performance. So we could do a giant slalom on Dendix. That's the stuff we saw at Sheffield, the hard bristle surface, and that gave us a 23% improvement in speed on a giant slalom course. So that's doing nice winding turns. If we go to a glide test like we do on snow, so that's going straight down the hill, on Dendix again we see a 32% increase in speed. So that's excellent. When we go into alpine snow, the type that we've got here, the increase in speed isn't as pronounced as on artificial snow, but it's still good. We're looking at 1 to 2% increase in speed.
That figure might not sound impressive, but to top-level racers, it's a huge advantage.
Actually, it can be the difference between finishing, let's say, 20th or being on the podium in first place.